Hello and welcome. We are in Numpy Arrays lecture here. After the installation of Numpy, you can import it as a library. Import Numpy as NP. Numpy has many built-in functions and capabilities. We won't cover them all, but instead we will focus on some of the most important aspects of Numpy. Vectors, arrays, matrices, and number generation. Let's start with Numpy arrays. Numpy arrays are the main way we will use Numpy throughout the course. Numpy arrays essentially come in two flavors, vectors and matrices. Vectors are strictly one-dimensional arrays and matrices are the two-dimensional, but you should note a matrix can still have only one row or one column. Let's begin our introduction by exploring how to create Numpy arrays. From Python list, we can create an empty array by converting the list or list of lists. Suppose we have my list 786 and just run it, then this is the list, one-dimensional array. So if we here the typecasting np.nparray my list, then it will generate it. So now it's saying that it's np is not defined, so let's execute it, and now let's execute this one. So this is the array 786. So it's typecasting for the my list to the np array. Suppose if we want to create the multi-dimensional array, then matrix is a multi-dimensional array like list of lists. Suppose here the list of multiple lists, and when we run it, then this is the 786 like the double brackets here. Now if we convert this typecast, this my matrix to array, then see here this is the array, multi-dimensional array, and where are the just the arrays like 786 one array, this is the another array, and this one is the third one array. So this is the double bracket, it's showing the multi-dimensional array. There are built-in methods, so we have a lot of built-in methods to generate the array. Suppose we have here the arange built-in method, which return the evenly spaced value within the given interval. Suppose np.arrange 0 to 20 and we run it, then it's come through 0 to 19. And if we want to show the array from 0 to 20, then we need to be the right here the like 21. Suppose here the np arrange 21, and here just how it looks like. This look like this way, and if we want to add the step in it like that, the gap size 0, 4, 8, 12, 16 and 20, like if you see here the 4 is the step size. Zeros and ones. Zeros and ones are the built-in functions. We can create the arrays of zeros and ones with the help of these functions. Here np.zeros3, so it will create a array for zeros with the count 3, and here we have the zeros with 7 and 7 tuple, so here it will be the 7 rows and 7 columns. Like this is the one row with 7 columns, 2, 3, 4, 5, 6 and 7, and also this can be reduced like 3 by 7. If you see here the 7 columns and 3 rows, and we make like the 2 and 7, so 2 rows and 7 columns. And in similar way we can create the arrays for the ones. Suppose np.ones 4 we have. So here this is the array of 4 ones, and we can reduce it like 3 as well. And here the ones with the tuple 4 by 4. So here the 4 rows and 4 columns, and with this and we can already change it as well, like the 2 rows and 4 columns in similar way. We have the linspace built-in function as well, which return the only the spaced numbers over a specified interval. Suppose we have the linspace here 0, 20 and 3. So run it, then it's 0, 10 and 20. So these are the count steps like that, the counts for this. And if we make it 10, then that will be the 0 and 20. And if we make it 4, then it will divide it to the 4 equal parts. Like if we make it 5, then it will make it 5, 10, 15 and 20. So linspace, the number over a specified interval here. So here suppose we have the linspace, suppose 100 and 50, then it will be the each will be the 2 and something. And if we make it like 10, then it will be the 11, 22, 33 and 100. So this is the linspace function, which returns the even the space number over a specified interval. So like 10 is the interval here, suppose. So I is also a built-in function which creates an identity matrix. So if we make it 5, then it will be the 5 identity matrix. If we make it 3, then it will create the identity matrix for 3. Like suppose 1, 0, 0. 0, 1, 1, 0, 0, 1. This is the identity matrix. We have a random built-in function. Numpy also has lots of ways to create random number arrays. So rand create an array of given shape. Rand will be used to create the array with the given shape and populate it with random samples from a uniform distribution over 0 and 1. Suppose here we have this np random.rand and 2, so it generated 0 and 1 distribution over it. And if we make it 4, then see, so it create the 4 distributions over 0 and 1. So the distribution over will lie 0 and 1. So from 0, 0, 0, 0 to 1, right? And here also we have the same tuple calling here, so it will generate the random numbers with the shape, and which for a uniform distribution of 0 and 1 create the array with the 4 rows and 4 columns. And also we have randn, which return a sample from the standard normal distribution, unlike which is uniform. Suppose we have randn here and see the results here. The results are the change comparatively from that. And here and the randn for standard normal distribution with the tuple 4 and 4 value. So it generate the you can say like sample for the standard normal distribution with 4 by 4. It will generate the random integer from 1 to 10, and here we have the same randint function with 1 and 100, and here the 5, so it will generate the 5 random integer values. Suppose here, and if we want to generate the 3 random integer values, then it will generate the 3 random integer values. Array attributes and methods. Let's discuss some useful attributes and methods for an array. Suppose we have an array np arrange 15 and then A rand array is equal to np.random rand integer from 0 to 100 and 10 from here. Suppose we run it and then AR, call it the AR. So this is the array of 15. And now this is the this is the for maximum the 10 from this 100, 0 to 100 range. Generate the random integers. And this is the array of those. We have reshape built-in function, an array containing the same data with the new shape. Suppose here cannot reshape array size of 5 into 4 by 4. So suppose here so now here it was 15 range. So here we're returning an array containing the same data with the new shape 4 by 4. This is the same data 0, 1, 2, 3, 4, 5, 6, 7. This is the same data which is the reshaped with 4 by 4 tuple. And also if we here make like that is 9 and run it through with this, and now here we can reshape it by 3 by 3 and it is now reshaped it like this way. So max and min, argmax and argmin, these are useful methods for finding maximum or the minimum value or to find the index location using the argmin and argmax. So here we have the rand array integer. This one is this. So let's find the maximum of this is 95. And argmax is the index for this is the 9. And here the rand array the minimum value, and now the index for this value is 7. We have shape is an attribute that arrays have. This is not a method, this is an attribute. Suppose array dot shape, so it's showing like that the 9, and notice the two sets of the brackets are shape 1 to this 9 into this 1 to 35 cannot reshape it. So let's make it so it's here the two sets of the brackets. So reshape it 1 to 9, reshape 1 to 9, and then again reshape it. Here we go. Let's see, 1 to 9, and then again reshape it is the 0 to 8 like this way, and then again reshape it by 9 and 1. We also have the dtype. You can also grab the data type object in array like that, the array.dtype. Here it's the dtype is integer 64. So excellent job. You are on the way to become a data scientist. This is all about the Numpy Arrays. I hope you are enjoying it. Please be practiced to become a data scientist. Thank you. I'll be back with next lecture.